Okay, so let's look at comparing ratios. We can figure out which, when we're looking at two ratios, if they're not in proportion to each other, one must be bigger or smaller than the other. Okay, so remember, if they're proportional, they're equal. Okay, if we looked at that, you can compare them as fractions. And once again, we're going to compare them as fractions. So which is the greatest ratio, 3 to 5 or a ratio of 2 to 3? They're fractions. So what the question is really, is the fraction 3/5 bigger or smaller? So remember our signs for that. Would 3/5 be bigger or smaller than 2/3? Remember, greater than, bigger is that symbol, less than is that symbol. So if you want to have the crocodile's mouth, if you want to have that, think about that, you'll be eating the bigger one. All right, so which is bigger out of these two is the question. Well, I'm not entirely sure because I can't compare them because these are fractions and they have different denominators. Remember, it's far easier to compare fractions when they have the same denominator. So we're back to common denominator here. So what's the common denominator between 5 and 3? Well, I definitely know 15 is one because 5 times 3 is 15. So I'll use 15. So if I have that out of 15 and this one out of 15, so in order to bring this one, so multiply by 3 and 3, top and bottom, to get to 15 on the bottom. So it'll be 9/15. So we should remember this from fractions, so I'm going through it quite quickly. Multiply by 5 and 5, we'll get this one to 15, so 10. Now we can clearly see which one is bigger because they're both out of 15. Easier to compare when they have the same denominator. 10 over 15 is greater than 9 over 15. So to compare ratios, step 1, convert them into fractions. Step 2, change the fractions to the same denominator, and then they can be comparable. So something interesting that this can be used for is to look at something called gradient, or a steepness of a line or a hill, in this case. So we've got a hill here that's, let's say, 3 meters across and 5 meters up to reach to its top point. So if you climbed this hill, or if you climbed one that was 4 meters and 7 meters up, which would be the more difficult hill to climb? So we could compare ratios for this, and this is called gradient. So the gradient of a hill is how far you go over versus how much you go up. Now if you think about that logically, it makes sense. If I have a really long, slow incline, such as this, that'd be a far easier hill. So let's say we have 10 meters and it goes up 1. What would be the slope or the gradient of that hill? Well, it's going to be how much it rises, in this case 1, over how much it goes over, that's 10. So that is the gradient of that hill in a ratio 1 or 10 to 1. 1 over 10. Okay, so for every 10 meters it goes over, it goes up 1. So that's pretty easy to climb that one. Well, look at these two then. Same thing. How far it goes over versus how far it goes up. So this one is going to be 5 over 3. So it's a top-heavy fraction. That's okay. And this one's going to be 7 over 4. Another improper fraction. But I still don't know which one's bigger. Don't know which one is bigger. I'm not entirely sure which one I'd rather climb. Well, if I could, I'd climb this one because for every 10 meters it goes over, it goes up 1. It's a very, very shallow slope, a very shallow gradient on that hill. So which one of these two is bigger? Well, in order to compare, I need to have a common denominator for both. So a common denominator between 3 and 4, well, there's plenty we could use. 12 is an obvious one. We could use 24. Let's use 12. Okay, so 5 over 3, rewritten as 12ths. If I multiply top and bottom by 4, I get 20 12ths. This one, if I multiply top and bottom by 3, so keep it the same, I get 21 12ths. And therefore, which is the more steep one? Which is the greater ratio? Which is the greater fraction? The one on the right, this is the steeper. This guy's going to be more tired than this guy. This guy is winning. He's a happy dude. He's got an easier slope to do. All or easier gradients. That's gradients. We can look at gradient of lines based across its horizontal on the bottom of a fraction and its vertical on the top of the fraction. So the x-axis, y-axis, if you wish to use it. So the horizontal goes at the bottom of the fraction here, and the vertical goes at the top of the fraction. And that's how we determine the steepness of mountains or of lines just. And we'll be looking more of that later on here. Okay, so that is how you compare ratios. So if they're not in proportion, if they're not equal as fractions, then one must be bigger than the other. And that's how we do it. Change them to fractions and then have the same common denominator before you can see which one's bigger than the other.